The James Webb Space Telescope was built to look into the distant past, capturing the first galaxies, studying the birth of stars, and revealing the hidden architecture of the universe through infrared light. But according to this narrative, what it found was far more unsettling than anyone expected. The deeper Webb looked into space, the less random the universe appeared to become. It revealed galaxies that seemed too old to exist, planets too massive for their own systems, perfectly formed rings of light shaped by gravity with astonishing precision, and invisible structures bending space where nothing visible could be seen. Hidden within one deep-field observation was even a series of faint pulses repeating with a rhythm that did not resemble any known star, quasar, or other natural source. At first, these observations were described as anomalies, then coincidences, and later as statistical accidents. Yet as the list of unusual findings continued to grow, the question itself began to change. Instead of asking whether individual discoveries could be explained away, some began wondering whether Webb was revealing something more profound, that the universe might be more ordered, more ancient, and more structured than existing models had ever predicted. In this telling, the telescope's discoveries are presented not simply as new scientific observations, but as a turning point where the cosmos appeared less like chaos and more like a carefully organized system. When James Webb first began scanning deep space, the public was captivated by the breathtaking beauty of its images. Golden arcs, ancient galaxies, and crowded fields filled with objects older and farther away than anything previously observed inspired or around the world. Yet beneath that beauty, the script suggests that something seemed unusual. In regions such as the galaxy cluster Abell 2744, Webb revealed points of light and structures that appeared strangely aligned. Symmetrical arrangements, repeating patterns, and remarkably clean forms seemed difficult to reconcile with a universe shaped by gravity, collisions, and billions of years of chaotic evolution. As additional observations accumulated, similar patterns reportedly appeared elsewhere. Spiral galaxies displayed motion that seemed difficult to explain with simple gravitational models, while deep-field images appeared to contain repeating structures across enormous distances. These observations challenged one of astronomy's most fundamental assumptions, that on the largest scales, the universe should appear statistically random. While not perfectly random in every detail, its overall structure was expected to show no hidden design. Yet according to the narrative, Webb continued revealing shapes that resembled geometry, raising deeper questions about whether these apparent patterns reflected real physical processes or simply the human tendency to recognize order. Scientists remain cautious because coincidence is always possible, and the human brain naturally searches for patterns even where none truly exist. However, the script argues that repeated coincidences eventually begin to feel less like chance and more like meaningful signals. Whether these observations represent unknown effects of dark matter, new aspects of gravity, or entirely undiscovered features of space itself remains an open question, but the deeper Webb looked, the more unusual the apparent order seemed to become. Another major challenge described in the narrative involves the discovery of massive, mature galaxies existing in the very early universe. According to current cosmological models, the universe followed a gradual timeline, first simple matter, then the earliest stars, followed by small galaxies that slowly merged and evolved into larger structures over billions of years. Yet Webb reportedly observed galaxies that already appeared bright, organized, and fully developed far earlier than expected, during a period when the universe should still have been young, turbulent, and dominated by raw gas. If these observations are interpreted as described, they raise profound questions. Either existing measurements are incomplete, or the standard story of how galaxies formed requires significant revision. The challenge extends beyond galaxies themselves. Webb has also observed planetary systems containing enormous planets orbiting surprisingly young stars at distances where conventional formation models struggle to explain their existence. Some of these giant planets appear to have formed without the time, material, or stable conditions thought necessary for their development. There are no obvious leftover disks of gas and dust, no straightforward formation pathways, and no comfortable explanations. It is almost as though fully formed worlds were placed into planetary systems before those systems had finished developing. According to the script, such observations leave science with two broad possibilities. Either current models of planetary and galactic evolution are incomplete, or the universe possesses a much deeper history than humanity has yet uncovered. While researchers continue to investigate these discoveries using established scientific methods, Each new observation encourages astronomers to refine and test existing theories. Some of Webb's most fascinating discoveries are not visible objects themselves, but the distortions they create in space. Massive galaxies can bend light through gravity, producing the phenomenon known as gravitational lensing. When a foreground galaxy lies directly in front of a much more distant one, its gravitational field warps space and bends the background light into arcs or even complete rings. This effect has become one of astronomy's most powerful tools for studying distant galaxies and invisible matter. Among these observations, the James Webb Space Telescope captured an exceptionally precise Einstein ring, a nearly perfect circle of light created by the alignment of distant galaxies across billions of light-years. Although gravitational lensing is a well-understood and entirely natural phenomenon, achieving such an almost perfectly circular ring requires an extraordinarily precise alignment between multiple cosmic objects. While such alignments are rare, they provide astronomers with valuable opportunities to study gravity, dark matter, and the structure of the distant universe in remarkable detail.